gonna click twice to go inside, and this is what we have. So we have these basic inputs, or these basic parameters that we have access to, immediate access to: position, velocity, force, age. Some of these attributes, or most of these attributes, aren't actually available. We have position so far, essentially, on our, if you middle mouse button here, you'll see our points only have curve view, position, tangent view, up, and that's basically it. So yeah, curve view, position, tangent, and up. Let's go to the point. Some of those attributes aren't here, but that's all fine. For instance, if we need to have access to curve view, we'll see how we can do that in a moment, but it's not one of the global attributes by default. And here we have the output. Again, the same thing. These are kind of standard outputs, but we don't need to use all of them. We're just going to be using essentially the position for now. And if we want to export something else, we also have a way of establishing another specific output for us. At this point, what I want to show you is how easy it is for us to generate randomness on this. So usually what we'll do is we'll use the position of each point to generate a noise. And let's start by the most commonly used, and it's versatile enough for us to use in this application, which is going to be a turbulent noise. You have different ways of working with turbulent noise. So turbulent noise can take different inputs, but it will usually take a vector position, and it can generate a float number, or it can generate a 3D noise. If you use a 3D noise, notice that the color has changed. So these green values are all vectors. If I change the signature to 1D noise, this is going to change to blue, and these are float values. Okay. For us, as I was saying before, we actually want to generate a random position for each point. So each point will have its own specific position, and we want that, use that to generate a noise. You have a lot of different types of noise. So here on the noise type, as you can see, we have a good amount of options, and the best thing to do is to just hit the help button here, and this will give you immediate access to what each specific noise is. But the most importantly, you'll also have access to what's the range of values that's returned by each one of these noises. So for instance, the original Perlin noise will have a range between -1 and 1. Perlin noise will be between 0 and 1. And then we have all the other ones. We're going to try with different ones and see which one we prefer. Let's go with that. But one thing I want to make sure is, I really want to make sure that the range of values that are being generated by the noise are actually both positive and negative. So I don't just want the ray to go being pushed in one direction. I want it to be able to push on both directions. So it's important for us to have negative and positive values. The original Perlin noise gives us values from -1 to 1, and that's good. That's what we're going for. So let's choose the original Perlin noise. And let's connect this. So we have the position. Each point has its own position. It's going to be fed into the turbulent noise, and each point will get a random 3D vector being generated by that noise. And what we want to do is add to the current position of the point, we want to add that vector. So we need to create an add operator, and we'll grab the position, and we'll add to that position the noise. And the result is going to return a new position for each point. And we get this effect. Okay. Now, if we switch, now let's see how the different parameters of the noise are going to affect this. let me just show you that. Okay, as you can see, all the points have been deformed. Okay, they're all out of place. We will need to have a way of making sure that these edges, the extremities of the line, are going to be kept at their original position. Back to the point VOP. So the turbulent noise will have a few parameters that are very important for us right now. So the main one is going to be the frequency, and this is going to determine how frequently the noise is going to change. So if we increase this number, here on the frequency name, I'm going to hold the middle mouse button and just start increasing this, let's say. And I'm doing this just so that we can increase all values at the same time. And as you can see, it's going crazier and crazier. If I middle mouse button and pull towards the other way, let me put this back at 1. So I'm gonna this, and let's put this at a low value. And as you can see, as I lower this, start to lower this, we get to 0, 0.1, almost no craziness, and then it starts to get crazier and crazier. So this is a very important parameter for us. I'm going to leave it at 1, the default. Then we have the amplitude. The amplitude basically just determines, it's like a multiplier for the value that's being generated by the turbulent noise. So with an amplitude of 1, we know that the original Berlin noise is going to be giving us values between -1 and 1. If we put a 2 here, we're going to be having values that go from -2 to 2, and so on and so forth. So now the vectors that are being generated for each point are much longer, are twice as long, and it's going to give us a more accentuated deformation. Hit escape. Let me put this back to 1. And roughness. Roughness is going to give us more contrast, more sharpness to the shape of the noise. So if we increase it, you'll see you get things more extreme. And if we bring it down, then we get something more wavy. Now, the attenuation is harder to explain, but the attenuation and the turbulence, this is the number of layers of noise that are going to be calculated. You can think about it that way. And the attenuation controls the way each one of these layers are being added on top of each other. Okay, so in essence, if we put this at 0.5, we get this type of effect. If we put this at 2, we get a completely different look. So you have to try out. I don't really change this value that often. Sometimes I do increase the number of turbulences, but for that to make sense, I will need to have a higher roughness just so that we can clearly see those big layers and small layers. So if I bring this down, you'll see we get just kind of a wavy shape. On top of this turbulence, we add a second turbulence, so we get a bit more distortion, and so on and so forth. You start adding more and more, and you get more distortion. Okay. But I'm going to keep it at the default value for now, 0.5, 0.5. Remember, whenever you want to go back to the default value of something, just hit Control middle mouse button on that parameter. Let's say I was doing something, just Control middle mouse button on the parameter. It's going to go back to the original value. So this was just a quick introduction to point VOPs and the system that we're going to be using.